Okay, so we got an important idea here. Lin polynomial, product of three linear factors, got wiggles if they got at least two distinct zeros. Okay? So, let's see what this means. Okay, now this is a cubic polynomial, so end behavior is opposite. Okay? You approach infinity at both ends and approach it more and more rapidly, and one end is down and the other end is up. So if we have three zeros, then the graph could look like this, or alternatively, like this. And we should be very familiar with why that works and how that works. Okay? If there are two zeros, so I can say if you have three distinct zeros, got to be one of these, either this graph or this graph, either the white graph or the green graph. Okay, now if you got two distinct zeros, and the coefficient of x cubed is positive, then you know that the graph overall is going to have the shape of an x cubed graph with wiggles in the middle, with possible wiggles in the middle. Okay, it might be vertically stretched and you don't know where the wiggles are going to be, but they're not going to be all that far from the origin, depending on how big the zeros are. Okay, so if you got two distinct zeros and the coefficient of x cubed is positive, then there are one of two ways this can happen. It's got to be down here, it's got to be up here. So it could do this. And notice that this is the same basic shape as this. It's just like if you take this one and move it down a bit, these two zeros kind of collapse into one. Okay, so it could look like this, or it could look like this. Okay? Ought to be. Okay? Now, if the coefficient of x cubed was negative, I'll just draw it real quickly. Well, then you just turn these upside down. I could draw them all in one picture. Then it would be like this, or like this. this or this if the coefficient of x cubed is negative. Now, this should all be pretty clear. And just for contrast, all three linear factors yield the same zero, then if, say, the zero is here, then the graph is going to act like this. Just like the x cubed graph. Your basic cubing function. Shifted so the x equals 0 or origin. Translates to the 0 on the graph. So you would be taking the x cubed function. Okay, I'll get the chalk to work down there. And shifting it every point over. Same number of units. Okay? And that's because if all three linear factors are the same, x minus 3 times x minus 3 times x minus 3, for example, would give you x minus 3 cubed. I.e., the x cubed graph shifted horizontally units. Now that would be this graph, because this graph, you'd have to have x plus whatever this distance is, okay? So if this is like -4, that would be x plus 4 cubed, and something you should simply understand. So we want to understand that. We want to understand these possibilities, and we want to understand the contrasting possibility, why three linear factors being the same would give us a simple transformation of the cubing graph.